Have you ever wondered, between the infinite universe above and the dark abysses at the bottom of the ocean, which is more mysterious? Both are worlds where humans can hardly survive. Cold, with air that cannot be breathed, and pressure strong enough to crush any creature. And surprisingly, although one lies in outer space and the other right here on our planet, they share astonishing similarities. The universe holds celestial bodies no one has ever touched, while the ocean hides countless strange creatures never before discovered by humankind. NASA is famous for its journeys to conquer space, but why are they turning their gaze down into the deep sea? The answer will surely surprise you. Join me until the end of this video to find out. And don't forget to subscribe to the channel so you won't miss the next exciting journeys of exploration. If you look at the map of our blue planet, you will see continents with familiar shapes, but few realize that most of Earth's surface actually lies beneath the deep waters. The ocean covers more than 70% of the planet's surface, yet we know far less about it than we do about distant planets out there. People often say, we know more about the moon than the ocean floor. This saying was true for many decades, and even today, it still holds a surprising degree of truth. Because even though modern measuring technology has advanced greatly, only about 23% of the ocean floor has been mapped in detail, while the moon and Mars have been almost completely scanned from orbit. It may sound paradoxical, but the reason is quite understandable. Space is vast and distant, but at least light and radio waves can travel through it easily. In contrast, seawater acts like a dense curtain. It absorbs light, chokes off electromagnetic waves, and creates crushing pressure the deeper you go. At the edge of the Mariana Trench, the deepest known point, the pressure is more than 1,000 times greater than the air pressure at the surface. Put a human down there and every cell would be instantly crushed. These extreme conditions make exploring the ocean far more difficult. However, it is precisely for this reason that the ocean is so strangely captivating. It is like a second universe right here on Earth, where eternal darkness reigns, life must adapt to survive, and any discovery could change the way we understand evolution and existence. When NASA began to turn its gaze toward the deep sea, many initially wondered, why would an aerospace agency care about the ocean? But if you look closely, it makes perfect sense. To prepare for journeys to distant planets, humans need an environment that closely simulates space, and the ocean is the perfect natural laboratory. In Florida, beneath the clear waters of the coral reef, lies a unique facility few know about, the Aquarius Reef Base. This is the only operational underwater research laboratory in the world, where humans can live and work for weeks at a depth of 19 meters. At first glance, it may not sound too impressive, but that very environment provides invaluable training opportunities for astronauts. The space inside Aquarius is narrow and cramped, forcing people to live under high pressure, control their breathing air, and coordinate closely just like on the International Space Station. Astronauts call it a window into space because the underwater experience closely resembles the feeling of weightlessness in space. Since 2001, NASA has used Aquarius to carry out the NEMO program, NASA Extreme Environment Mission Operations. In these missions, crew members must live and work continuously in the confined environment, conducting simulated spacewalks right on the ocean floor. They wear special diving suits, move slowly through the water, and learn to coordinate every action as if floating in orbit. Amazingly, more than 20 NEMO missions have taken place, bringing together astronauts from many countries, lasting for weeks at a time. This is where plans for conquering the moon and Mars are tested right here on Earth, in an environment both familiar and alien. But the ocean is not only a training ground, it is also a mirror of what we expect to find on the icy worlds of the solar system. Think of Europa, Jupiter's moon, or Enceladus, Saturn's moon. Both hide beneath ice layers tens of kilometers thick, vast oceans that may contain more water than all of Earth's oceans combined. And just like in the deep seas of Earth where sunlight cannot reach, those worlds may host life sustained by energy from within the planet. Hydrothermal vents, where hot, chemical-rich water gushes out, nurturing entire strange ecosystems. Exploring Earth's oceans not only helps humans better understand our home planet, but also opens the door to glimpsing the possibility of extraterrestrial life. Because if bizarre creatures can thrive at depths of more than 11 kilometers in the Mariana Trench, under pressures thousands of times greater than normal, then why couldn't other creatures exist in the oceans out there? That is why mapping the ocean, developing autonomous diving robots, or training astronauts underwater are not simply ocean studies. They are part of a greater journey, preparing humanity to step beyond Earth while facing the biggest question of all: are we alone in the universe? When talking about space exploration efforts, people often think of giant rockets, advanced spacecraft, or orbiting laboratories. But few know that, to prepare for journeys to distant worlds, NASA has had to test technology right on the ocean floor, because it is precisely there, the dark and extreme Hadal Zone, that truly simulates what may await us in extraterrestrial oceans. A prime example is the story of Nereus, the unmanned submersible expected to become the golden key to deep sea exploration. In 2014, it was sent down into the Kermadec Trench off the coast of New Zealand, one of the deepest places on the planet. At first, everything went smoothly. Nereus had once successfully dived to depths of more than 10,000 meters, a rare feat in history. But then, in just a moment, the crushing pressure of the Hadal Zone destroyed it. Fragments of plastic floating to the surface stood as proof of the challenge that human technology still faces. That loss was not only a technical failure, but also a reminder that we are still taking our first tentative steps at the threshold of the abyss. From that failure, NASA and its partners learned many valuable lessons. The successor to Nereus, a compact submersible robot named Orpheus, was designed to be lighter, more flexible, and better adapted to harsh conditions. Instead of attempting to plunge immediately into the deepest zones, Orpheus is being tested in shallower environments where scientists can monitor, adjust, and optimize. If everything succeeds, this very compact design will make it a top candidate for a far more distant mission, exploring the ocean of Europa, Jupiter's icy moon. That vision may sound like science fiction, but it is gradually becoming reality. In 2023, NASA convened a special conference at the California Institute of Technology, gathering more than 40 leading experts in oceanography, robotics engineering, planetary science, and astrobiology. The conclusion was groundbreaking. With current technology, sending an autonomous submersible to explore Europa's hidden ocean is no longer a distant dream. In fact, it may be the most feasible way to directly search for signs of extraterrestrial life in the near future. Just imagine that moment, a small human-made craft piercing through tens of kilometers of ice, then drifting silently in the dark, frozen waters beneath Europa's surface. Around it, there might be hydrothermal vents releasing white plumes, or bizarre creatures hiding in the shadows. That scene would be both alien and familiar because the ocean has always been the cradle of life on Earth. If life can emerge on a second planet within the same solar system, then the possibility of it being widespread throughout the universe becomes entirely plausible. Of course, many obstacles remain. One of them is energy. To operate a robot beneath an ice layer tens of kilometers thick, we cannot rely on conventional batteries. Scientists have considered using miniature nuclear generators to provide heat and electricity while also melting the ice to create a path for the robot to descend. The next problem is communication. Radio signals cannot penetrate the thick ice, so a massive fiber optic cable would need to be deployed along the robot's path, both to transmit data and to provide backup power. All these challenges make every small step in undersea testing on Earth's ocean floor incredibly valuable. From this, we can see the importance of studying the deep ocean at home. Robots like Orpheus are not only for space objectives. Right here on Earth, they can also help us map areas never before touched, from the Mariana Trench to other still mysterious Hadal regions. This offers a double benefit, serving planetary science while helping us better understand the fragile ecosystems of the ocean depths, which hold many keys to the issue of climate change. And that is only the beginning. Imagine if one day we discover extraterrestrial life, even if only single-celled microorganisms in Europa's hidden ocean. It would completely change how humanity perceives itself, because life would no longer be rare, but instead an inevitable rule whenever the conditions are right. That would also mean that somewhere in the Milky Way, other civilizations may exist, diverse forms of life, waiting to be discovered. To reach that day, NASA still needs many decades of testing and refinement. But that journey, in a sense, has already begun from Earth's ocean floor. It is this dark realm on our own planet that has become the training ground for humanity's most distant voyages. And it is also a humble reminder. Before dreaming of reaching the stars, look down into the ocean, where more than 70% of the surface still remains unexplored by humankind. When mentioning the invisible forces that keep our planet stable, most people will immediately think of gravity or Earth's magnetic field. But now, with the latest discoveries, we know that there exists a third energy field, the ambipolar field, which plays a far more important role than we ever imagined. If gravity keeps humans and oceans firmly on the surface and the magnetic field protects the atmosphere from deadly radiation from the sun, then the ambipolar field is the missing piece that explains how Earth has maintained a stable living environment through millions of years of cosmic turbulence. To understand more clearly, let's start with plasma, the most common state of matter in the universe. Unlike solids, liquids, or gases, plasma exists as an energetic sea of particles where electrons and ions separate, moving freely, forming a strongly conductive mixture. The dazzling auroras in polar skies or the lightning flashes in violent storms are vivid proof of plasma's presence around us. But more importantly, plasma in the upper atmosphere is the environment that nurtures and gives rise to the ambipolar field. So, what exactly is the ambipolar field? Imagine the atmosphere as a transparent ocean where charged particles are constantly moving. Since electrons are lighter and more flexible than ions, they move quickly, leaving behind a charge imbalance. This difference creates a special electric field capable of pushing or pulling charged particles in a specific direction. In other words, the ambipolar field is the invisible arranging force that maintains energy balance and prevents Earth's atmosphere from breaking apart and dispersing into space. Without this field, light gases such as hydrogen or helium could have escaped from the atmosphere billions of years ago. That would have turned Earth into a barren world, like Mars, where a thin atmosphere is not enough to shield the surface from ultraviolet rays. The ambipolar field, in a way, has acted as an energy net that retains vital components, sustaining the cycles of water and gases necessary for life. This may be the core reason why our planet differs from its neighbors. What is noteworthy is that the existence of the ambipolar field is not just of pure scientific significance. It opens up an entirely new direction in studying the habitability of exoplanets. When scientists search for worlds that can sustain life, they do not only focus on the Goldilocks zone, where a planet is warm enough to have liquid water, but must also consider whether the planet has sufficient energy fields to protect its atmosphere. If a planet has gravity and a magnetic field, but lacks an ambipolar field, its atmosphere could gradually be blown away, turning it into a cold, dead land. So then, could extraterrestrial life be more abundant than we think? The answer may depend on whether those distant worlds have an invisible shield similar to Earth's. Recent simulations by NASA and ESA show that within the solar system, not only Earth, but also Saturn and Jupiter exhibit strong ambipolar fields, especially near the poles where cosmic auroras dance. This suggests that the icy moons orbiting the gas giants, such as Europa or Enceladus, may be indirectly protected by this energy effect. And if the subsurface oceans beneath their tens of kilometers thick ice layers are stable, microbial life could very well exist. Back on Earth, the direct detection and measurement of the ambipolar field has helped scientists solve mysteries that persisted for decades. Previously, they had observed high-altitude gases escaping into space, but did not understand the mechanism controlling the speed and extent of that escape. Now, the answer is clear. It is the ambipolar field that serves as the energy gateway, determining which gases are lost and which are retained. In fact, fluctuations of this field are directly linked to climate change, as it influences how Earth balances energy with space. Thinking more broadly, we can see a profound connection. It is these invisible energy fields that created the conditions for human civilization to form and thrive. From the first agriculture in Mesopotamia to today's modern cities, everything relies on a stable atmosphere and a relatively balanced climate. And for that balance to exist, not only gravity and the magnetic field, but also the silent contribution of the ambipolar field have been essential. Of course, its discovery also gives us a warning. If this planet can sustain life thanks to such a complex energy system, then disrupting atmospheric balance by releasing billions of tons of greenhouse gases each year is like removing the protective net ourselves. Even though energy fields can keep the atmosphere from being blown away, they cannot prevent Earth from becoming a sweltering greenhouse where the poles melt and ecosystems collapse. This raises a major question. What choice will we make? Continue exploiting resources and leaving natural energy systems to strain under the burden, or learn to understand and respect them, thereby finding solutions to live in harmony with the planet? History shows that every time humanity has understood more about a natural mechanism, we have had the opportunity to change, like when the discovery of the ozone hole led to the Montreal Protocol, which significantly reduced CFCs and saved the sky. Could the discovery of the ambipolar field be the next turning point, reminding us that even invisible forces have their limits? When you look up at the night sky and see auroras dancing in the polar regions, remember that it is not just a beautiful sight. It is proof that this planet is functioning like a giant energy machine, connecting force fields to protect fragile life. And within that machine, the ambipolar field, a new but promising discovery, may be the key to helping us better understand not only Earth, but also the future of life in the universe. If we consider Earth as a gigantic ship traveling through space, then the atmosphere is the fragile protective shell that allows the passengers, us, to exist. But what is astonishing is that this shell is not static. It breathes, it oscillates, and it gradually loses matter into the cosmos. This phenomenon, called the polar wind, is evidence that our planet is not sealed like an immutable sphere, but continuously exchanges energy with space. It is precisely at the north and south poles, where magnetic field lines open, that the polar wind carries away cold plasma, mainly hydrogen and helium, escaping into space, forming an invisible flow with far-reaching impact. When scientists first observed this phenomenon in the 1960s, they were puzzled. According to all familiar thermodynamic models, only heated particles should have enough energy to escape gravity. Yet, instead of being hot, the plasma particles were unusually cold but still raced away at supersonic speeds. This forced them to consider a non-thermal mechanism, some invisible force, that was driving them off Earth. And then after decades of research, the answer gradually emerged: the ambipolar field. The ambipolar field can be imagined as a global electric field, formed from the imbalance between lightweight electrons and heavy ions in the ionosphere. Electrons, being too small and too agile, are constantly pushed away by solar photons. Meanwhile, the heavier positive ions are held back by gravity. This separation creates an electric potential, a subtle force but strong enough to accelerate plasma. That is the engine of the polar wind, a motor that needs no heat, no combustion, relying solely on the charge imbalance to blow hydrogen, helium, and a small fraction of other gases into space. What is notable is that the polar wind is not just an interesting detail in atmospheric science. It is also part of the larger story of atmospheric evolution and a planet's ability to sustain life. Consider Venus. At one point, this sister planet may have had oceans hundreds of meters deep, yet over billions of years, water almost completely disappeared. One plausible explanation is Venus's unusually strong electric field, about 25 times stronger than Earth's, which pulled oxygen out of the atmosphere, breaking water molecules and leaving the planet desiccated. By contrast, Earth's electric potential is much weaker, like a thin watch battery. Weak, yet just enough to create the polar wind, and at the same time not too strong to strip life away. This just right balance has allowed Earth to maintain its fragile equilibrium for billions of years. Thanks to this, water, the essence of life, was not completely lost. But it also reminds us that the atmosphere is not immutable. Earth is gradually losing hydrogen and helium at an estimated rate of about 95,000 tons of hydrogen and 1,600 tons of helium per year. This number may sound enormous, but compared to the mass of the atmosphere, it is just a drop in the ocean. However, on the scale of billions of years, even such small flows are enough to change the picture. An intriguing question arises: how will the polar wind shape Earth's future? If hydrogen continues to escape, Could this affect the water cycle in the long run? Is it possible that billions of years from now, Earth will dry up like Venus? Current models suggest that the present rate of loss remains within the safe range, since water on Earth is continually replenished through the hydrological cycle and geological processes. But the story of Venus is a clear warning that this balance can be disrupted if a major variable, such as a change in solar activity or human interference, comes into play. Research on the polar wind also opens a broader perspective: the search for life beyond Earth. For a planet to nurture life, retaining a thick atmosphere and liquid water is just as important as being in the Goldilocks zone. When astronomers observe exoplanets tens of light years away, estimating whether they have a stable ambipolar field may become a crucial criterion. Without this mechanism, even an Earth-sized planet in the ideal position could turn into a barren wasteland. What makes the polar wind even more fascinating is its paradoxical nature. On one hand, it is a silent threat, gradually draining our atmosphere. On the other hand, it is also the regulating mechanism that allows the planet to breathe and maintain energy balance. Without the polar wind, the ionosphere could accumulate too much energy and fall into disorder. In a way, the polar wind is like the breezes in the planet's lungs, helping Earth maintain a steady rhythm of life over time. But to measure such a delicate phenomenon, humanity had to spend decades of patience and technological development. The success of the Endurance mission in 2022, which recorded a change of just 0.55 volts in the ionosphere, marked a major breakthrough. Although this number is so small as to be almost meaningless in everyday life, it was enough to explain why cold plasma could still escape into space. That is the power of science, turning tiny signals into answers to grand mysteries. In the bigger picture, the polar wind reminds us that life does not exist thanks to a single factor. It is the result of overlapping mechanisms, from gravity, magnetic fields, solar radiation, to the ambipolar electric field. If just one of these pieces shifted out of place, this planet might no longer be suitable for life. And that is precisely why understanding the polar wind not only satisfies our curiosity, but is also part of the journey to protect our only home. When you look up at the brilliant aurora in the sky, remember that behind those shimmering lights lies a complex physical mechanism. Each green, red, or purple glow is proof of the ongoing dialogue between Earth and the universe, where plasma particles are accelerated, pulled, and sometimes lost forever. It is not only a magnificent natural phenomenon, but also the background music of life, quietly playing for billions of years. When looking up at the night sky, we often think of eternity, of distant stars that seem immutable over billions of years. But the reality is different. Our Earth is not an indestructible fortress. It too is gradually changing. Every day, thousands of tons of atmosphere are swept into space by the solar wind and other escape processes. Yet, astonishingly, the planet has maintained a stable atmosphere for billions of years, enough for life to flourish. The deeper reason lies in seemingly invisible physical mechanisms, one of which is the ambipolar electric field surrounding the atmosphere. This electric field, though weak, acts like a shield that helps Earth retain most of its water and oxygen, the foundational elements for life. Imagine this: the lightest hydrogen ions can easily be blown away by the solar wind. But when it comes to oxygen ions, much heavier particles, crucial for forming water molecules, the ambipolar field intervenes. By reducing their effective weight as they move through the ionosphere, this field allows oxygen to exist at higher altitudes, helping the atmosphere remain denser and more resilient than it otherwise would. Thanks to this, Earth has retained water for billions of years, while its closest neighbor, Venus, failed. Venus also has an atmosphere, even denser than ours, many times over. Yet, instead of becoming a lush paradise, it turned into hell, with temperatures hot enough to melt metal. The key lies in the difference in electric potential. Venus's atmospheric electric field is nearly 20 times stronger than Earth's, strong enough to pull even heavy particles like oxygen out of the atmosphere. Without oxygen, water cannot exist. And when water disappeared, the greenhouse effect ran out of control, turning that planet into a gigantic furnace. These discoveries not only help us better understand Earth, but also reveal how life may exist or not on other planets. If every planet with an atmosphere has its own electric field, then its intensity and structure may be the decisive factor in whether a world has the conditions for life. Recent measurements from the Endurance Project have opened the door to fascinating scientific questions. Could we predict the lifespan of a planet simply by observing its electric field? Could we find second Earths in the universe by better understanding this mechanism? Alongside exploring atmospheric mechanisms, humanity is also turning its gaze toward Mars, the barren red planet that nevertheless reminds us much of Earth. NASA's Mars Reconnaissance Orbiter, MRO, has captured millions of images over more than a decade, painting a detailed picture of this planet's surface. One of the most fascinating scenes is the dunes. At first glance, they seem familiar because dunes are also iconic images of the Sahara, Gobi, or Namib on Earth. But upon closer comparison, we realize that Mars has unique types of dunes not found on our planet. On Earth, common types of dunes, such as crescent-shaped barchans, dome dunes, or star dunes, are formed mainly by wind and vegetation. Each type has its own distinct shape, telling the story of atmospheric flows and the terrain where it sits. What astonishes scientists is that on Mars, although atmospheric pressure is only 1% of Earth's, the winds are still strong enough to move sand grains. Moreover, the sand grains on Mars are much smaller, making them easier to be carried away, forming mobile dunes that shift over the years. This shows that Mars's climate, though harsh, is more dynamic than we imagined. Straight dune fields stretching hundreds of kilometers, or towering star-shaped dunes, remind us that the red planet is not entirely silent as it appears. On the contrary, it is quietly changing every day, much like how our Earth keeps transforming under the influence of wind, water, and time. From this perspective, it is hard not to think of the deep connection between phenomena, from hydrogen ions escaping into space to the silent movement of dunes on another planet. Both, though different in scale, tell the same story, that the universe is a living entity, constantly in motion, and humans, with endless curiosity, are tracing those signs to piece together the bigger picture. Reflecting more deeply, we see how special our planet truly is. Earth is not only fortunate to lie within the habitable zone distance from the sun, but it also possesses subtle micro-level factors, like a weak ambipolar field that is nonetheless strong enough to retain water. This fragile balance has nurtured all life, and it is precisely this that makes us treasure what we have even more, from the delicate atmosphere to every clear drop of water. While scientists continue to send probes, satellites, and robots across the solar system, perhaps the deepest message comes from our own home, that life is not a given. It is the result of countless subtle interactions over billions of years. And if we truly understand how Earth operates, we will not only protect ourselves, but also gain the chance to recognize life, if it exists, on distant worlds. When approaching the poles of Mars, we step into a landscape both strange and familiar. Massive sand dunes lie still under the dim light, yet they are not dead. When spring arrives and temperatures rise, the thin layer of carbon dioxide ice covering the surface begins to sublimate, transforming directly from solid to gas. This process releases enough energy to blow away loose material, creating streaks of light and shadow stretching across the surface. The result is bizarre, natural paintings that only Mars can offer, a testament that the red planet is not as silent as many might think. One of the most striking images was captured at the exact moment of sunrise. Light slanted across the horizon, casting long, sharp shadows from the dune ridges, bringing a rare three-dimensional sensation. The viewer does not only see the planet's surface, but also feels as if standing within the scene itself, perceiving the height, depth, and immense scale of dunes stretching for kilometers. This is no longer just a scientific photograph, but an artistic moment of nature, capturing the interplay of light and terrain on a distant world. But Mars does not stop at its giant dunes. Remember the feeling of walking along a beach on Earth, where wind and waves leave small ripples on the sand. On the red planet, a similar phenomenon occurs, but on a far larger scale. These ripples are spaced 1 to 2 meters apart, many times larger than those on Earth's beaches. They are so large that the Curiosity rover was able to observe and record them. The existence of these giant ripples once surprised scientists, reminding us that Mars still holds countless mysteries waiting to be unraveled. What makes these phenomena so valuable? The answer lies in this. Every trace on the Martian surface is a clue to the planet's climate history and dynamics. The sublimation of carbon dioxide ice or the wind carving patterns into dunes all reflect how the atmosphere, fragile as it may be, is still active. We often think of Mars as a dead world, but clearly it is still changing day by day. And in that change, we may find crucial clues. Did this planet once have conditions suitable for life, and could it support life in the future? Exploring natural phenomena on Mars not only satisfies curiosity, but also expands our understanding of Earth. Comparing the two worlds shows us what makes our planet special: an atmosphere thick enough to sustain liquid water, a balanced system between solar energy and a magnetic field to preserve life. While Mars gradually lost its air and became a frozen desert, Earth still maintains the cycles of water, air, and diverse life. It is this contrast that makes every image from orbiters not only beautiful, but also full of philosophical meaning. Curiosity, perseverance, and their siblings are not just scientific tools. They are our eyes gazing into another world. Images of dunes, ice, and sand ripples on Mars are visual stories, recording the history and present of a planet. And through them, we not only learn what Mars has, but also gain the chance to compare and understand Earth more deeply, the only home of life we know. What makes these discoveries profound is their ability to spark imagination. When seeing endless dunes under the Martian sunrise, one can imagine a day when human footprints will be pressed there. When looking at the giant sand ripples, we think of the cold winds blowing, carrying red dust across the planet. And when watching CO2 ice sublimate, we realize that even in the harshest conditions, nature still operates with delicacy and order. The truth is this: the journey of exploring Mars is not just science, but also a journey of emotions and aspirations. It reminds us how vast the universe is and that every small discovery contributes to building the larger picture of our place within it. We still have thousands of unanswered questions. Did Mars once have oceans? Did microorganisms ever exist there? And if so, what traces have they left in its soil and dust? The giant dunes, the mysterious ripples, or the sublimating ice may only be the tip of the iceberg, opening the door to much greater stories. And that is precisely why humanity continues to invest, continues to send probes, continues to look toward the starry sky. Because every image, every measurement is not only data, but also a piece of the puzzle in the search for meaning, where we came from, and whether there is another place in the universe that once or will harbor life. As we close this journey of exploration, one thing becomes clear. Mars is not just a barren, red planet as we often imagine, but a vibrant world full of mysteries waiting to be unraveled. From massive dunes stretching for kilometers to delicate ripples spread across the surface, this planet reminds us of an early Earth, both familiar and alien. Each image sent back by the probes is like a small doorway into uncharted land, and the more we look, the more we realize how much remains unknown. What impresses me most is not just the visual beauty of the images, but the scientific stories hidden within them. A streak of light on a dune is not merely a bright line. It is the trace of carbon dioxide sublimation, a climatic mechanism that even Earth can hardly replicate. A long shadow across the surface is not just the randomness of sunlight, but a clue helping us understand the structure, height, and form of those colossal dunes. Even the tiny ripples, so easy to overlook, contain within them an entire system of winds, atmosphere, and planetary dynamics. From afar, they seem ordinary, but through the lens of science, they are nature's script, left for us to read and decipher. When Curiosity or any other probe captures such scenes, they are not only recording images, they are transmitting questions to us. Why did these structures form? How do they change over time? Could it be that millions of years ago, wind, ice, or even water helped shape them? And more importantly, what story can all these tell us about the potential for life on Mars? Let's take a step back. Humans are accustomed to searching for life in grand and visible things: vast oceans, endless forests, or at least rivers and streams. But history of science has often proven that life hides in small, seemingly insignificant places. Microbes in icy cracks, in arid soil layers, or even in underground aquifers deep beneath the ocean floor. And if our Earth can produce life from such places, why couldn't Mars? That is the wonder of studying the red planet. Every discovery, no matter how small, shakes our perspective of the universe and of ourselves. Looking at the dunes of Mars, we see not only a distant desert, but also the reflection of Earth, of the beaches we have walked, of the winds we have breathed. That planet seems to be telling us we are not alone in this universe. Perhaps not in the sense of intelligent neighbors, as we often imagine, but in the sense of natural laws, physical phenomena, and climatic cycles that are universal, connecting worlds together. When thinking of the future, I believe the images we see today are only the beginning. One day, humans will set foot on those dunes, touch the fine soil beneath their feet, and directly feel the power of Martian winds. That day may not come soon, but every mission, every piece of data, every image sent back is a small brick building the road leading us there. And perhaps when we set foot on the red planet, we will not only discover a new world, but also learn to look back at our own Earth with different eyes, more appreciative, more profound, and more humble. Therefore, this journey is not only a story of science or technology, it is also a story of human faith and curiosity. We look up at the night sky and wonder if we are alone. We look at images from Mars and wonder what else is hidden. It is these questions, not the answers, that drive us forward. Thank you for accompanying me to the end of this video. If you found these discoveries as fascinating as I did, stay tuned, because the journey is long and the greatest wonders may still be waiting ahead. And don't forget, every subscription, every support of yours not only keeps the channel alive, but also helps sustain the spirit of exploration, the very spirit that carried humanity from Earth's shores to the distant dunes of Mars.